evening. We'll look into some problems on measures of spread. We'll try to compute the same thing. We'll be using the same set of questions. I think it is shared with you on 21st June. Any questions with open mark? So I'll take one under raw, discrete, and continuous case and help you out in obtaining the measures. So let me take 1C first. Okay, so I'll teach how to obtain quartiles, deciles, quartile deviation, standard deviation, and one of the mean deviation. And I'll give you some more set of problems as homework and expect you that as an assignment. So let me first write the values. I will take it as x. So I have 3.5, 3.1, 2.1, 2.5, 2.8, 3.2 and 3.4. Okay. So I'll make a list what all will do to this. We will obtain QD and coefficient of QD. And since it is raw data, you can talk about range, coefficient of range. And let me obtain some deciles also. So let me talk about say D3 and D8. Maybe a percentile, D20. And then of course standard deviation, variance. We have talked about AM, GM, HM, median and mode. So I'll be not covering them again. If required, we need mean for standard deviation. In that case, we'll pick up that. And then we have IQR. And then for this measure, I will talk about mean deviation from mode. There are two more, so let me take mean deviation from median. So this will be specified in the question. When the examination and test problem will be given, one or two measures like this will be specified. As we know that this is a practice session, so we'll look into try to understand most of the measures. Okay. So first, we have much of the partition values here. I need quartiles, I need median, again deciles, percentile, and quartiles for these things. So we have to first arrange the data in an order whenever we are obtaining the values of the quartiles. So that will also be x, and we can use the same set of x, the average values also in obtaining the mean. The total and other things doesn't change. So we have x values, very first value 1.9, then I have 2.1, 2.1, and then 2.5, 2.8, 2.9, then I have 3.1, 3.2, 3.4, and 3.5. 2, 4, 6, 8, 10, 12. Count your n so that we will make sure that none of the values are missed. So we have 12. Okay, so we'll obtain the total of this because we need standard deviation, and for standard deviation we need the value of mean. So please use your calculator. So we'll have 1.9. We have already computed mean in the last section, and use that also. We'll have a practice. Comes to 33.7. So we need quartile deviation. To find quartile deviation, I need Q3 and Q1, and the same is required for IQR also. So we'll write the formula for Q1. So if you remember the formula, Q1 is the first quartile, and for raw data, it is the value of x at position n plus 1 by 4. So I had given you general formula by stating qi equals I n plus 1 by 4th value of x. The same thing, we are taking I is equal to 1. So when I is equal to 1, so we get q1 is equal to n plus 1 divided by 4. Now we have n is equal to 12. Okay, so this will be 12 plus 1 by 4th value of x. 12 plus 1 is 13. 13 by 4 comes to 3.25. So this is 3.25th value of x. So whenever you have a position of some partition value, it could be decile, it could be percentile, or it could be quartile. In that case, you have to expand the position. Now we know that 3.25 actually lies in between third and fourth value. So it is somewhere in between third and fourth. Always take the arranged data while measuring the quartiles or partition values. So this 3.25 now can be extended. Third value plus 0.25 into fourth minus third. Why are we using this expansion? What is it telling? It is telling you that your value is in between these two such that it is 25% of times closer to our third value. So we have to talk about the difference between these two, and 25% of the difference has to be given to the third value. So there goes the expansion. So every number, every position where you're getting decimal part, that has to be expanded. Now suppose say in D3, if you get it as say 3.8 value, then you'll expand this as third value plus 0.8 into fourth minus third. So if you get any other position like 6.9, then that will be sixth value plus 0.9 into seventh minus 6. So that is how the expansion. Now once the position is expanded, now substitute the values. Third value is 2.1 plus 0.25 into fourth value is 2.5 minus third value 2.1. So first solve the values within the bracket. So 2.5 minus 2.1 is 0.4. 0.4 into 0.25 gives you 0.01. So you have 2.11. So real one. 0.25 into 0.4 is 0.1. So in that case it becomes 2.2. So this is our Q1. Okay, so don't forget to substitute and simplify. So we got Q1. Now similarly obtain Q3. Q3 is the value of x with respect to 3 into n plus 1 by 4th value. So when I put n is equal to 12, I get 12 plus 1, 13 by 4. 3 into 13 by 4 gives me 9.75th value. So again, I have a decimal part. So 9.75 means it is in between 9th and 10th value. That is 3.2 and 3.4. So I'll expand this 9th plus 0.75 into 10th minus 9th value. And do the substitution. 9th value is 3.2 plus 0.75 into 10th value is 3.4. 3.4 minus 3.2 is 0.2. 0.2 into 0.75 is 0.15 plus 3.2 is us 3.35. So this is our Q. So don't just end at the position. Position compute ಮಾಡ್ಬಿಟ್ಟು 9.75 is Q3 and then 3.25 is Q1 and the position ಮಾತ್ರ ಹೇಳ್ಬೇಡಿ. After computing the position, if you get a decimal position, expand it like this. If you are not getting a decimal, suppose your answer is just third value, and you can directly pick the third value. If it is say 8th value, pick the 8th value. You can easily write it. Problem is only when the position is in a decimal form like this. So now you got your Q1 and Q3. So you can compute IQR. IQR is given by the formula Q3 minus Q1. Therefore, this is 3.35 minus 2.2, which comes to 1.15. Yes, ಬರ್ಕೊಳ್ಳಿ ಜೊತೆ ಜೊತೆಯಲ್ಲಿ please be writing. And next we have quartile deviation QD. QD is given by Q3 minus Q1 divided by 2. We'll have 3.35 minus 2.2 by 2, which comes to 1.15 by 2, which is 0.675. So that is the quartile deviation. Then we have coefficient of quartile deviation. Coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1. So this will be 3.35 minus 2.2 divided by 3.35 plus 2.2. So 0.207. And what are these values? These are all the weights of some newborn babies, which are in kgs. So be careful whenever you have been given with the units of measurement. Almost of the measures of central tendency and dispersion, measure of position, they will carry the same unit. So please add the unit for Q1 also. Q1 is 2.2 kgs. Q3 is 3.35 kgs. IQR also carry the same unit. QD also carries the same unit, but coefficient of QD, so I have kgs and kgs in both numerator and denominator, the unit gets cancelled. So it is a unit-free measure. So this is about QD, coefficient of QD, and then IQR. And we have range and coefficient of range. And then we will look into D3, D8, P20 also. So clear this part. We have x values already written there. Now we know range. Range is highest minus lowest. Now in the given data, highest is 3.5, lowest is 1.9. Therefore, the range is 3.5 minus 1.9, which comes to 1.6 kgs. And then coefficient of range. Coefficient of range is h minus L by h plus L. So this is 3.5 minus 1.9 by 3.5 plus 1.9, which comes to 1.6 divided by 5.4. That is 0.2963. So this is coefficient of range. So again, no unit for the coefficient. For any measure, if you obtain coefficient, don't attach the unit of measurement given in the question. So we're done with this also. Now we'll look into D3, D8, and P20. So let's clear this part. ಆಯ್ತಾ ಇದು IQR and QD ಆಯ್ತಾ D3 decile, third decile. Decile is given by any I at the decile is I into n plus 1 by 10th value of x. So this is the position. So we have I as 3. So D3 will be 3 into n plus 1 by 10th value of x. When I substitute n equals 12, I get 3 into 13 by 10, which comes to, make sure that you are writing the value as, TH, indicating the position. 3 into 13 is 39. 39 by 10 is 3.9. So this is 3.9 value. Now you do the similar expansion. Third value plus 0.9 into fourth minus third. So third value we have 2.1 plus 0.9 into fourth value is 2.5 minus 2.1. 2.5 minus 2.1 is 0.4. 0.4 into 0.9 is 0.36. 0.36 plus 2.1 comes to 2.46 kgs. So the third decile of this distribution is 2.6. Now give me the answer for D8. Write the formula for D8. Compute and let me know the value. Same formula, D8, 8 into n plus 1 by 10. So just remember the common formula. Di is 5 into n plus 1 by 10th value of x. So D8 is 8 into n plus 1 by 10. Now put n is equal to 10 and tell me what is the position you get. Waiting for the response.
Three point four.
3.4 is position. No. Or the answer. I think you're giving me the answer.
Answer.
D8 is 3.4 kgs. Position is 8 into 13 by 10. 10.4th value. So it is in between 10 and 11. Since 10 and 11 both are 3.4, 10.4th value is also 3.4. So do a similar expansion to get 3.4 minus 3.4 times of 0.4, which is 0. So you have 8 value on. Fine. D8 is this. Now percentile P20. P20 is equal to 20 into n plus 1 by 100th value. So when you put n is equal to 12, 12 plus 1 is 13, 13 into 20 is 260, that divided by 100 gives you 2.6 value. The 2.6 value of x. Simplify that. I'm going to list of the quadrates. We need this Q1s, 2.2 kgs, Q3s, 3.35 kgs. So this is between second and third. So you have both second and third value as 2.1. So your answer will be 2.1. Third minus second. So you have 2.1 plus 0.6 into 2.1 minus 2.1. So this becomes 0. So I end up just having the P20 plus 2.1 kgs. Next is standard deviation and variance. Now we will use the simplified form. Now there are two formulas for standard deviation, one for frequency case and one for raw data. For raw data, it is sigma x minus x bar whole square divided by n. And as said, this takes much time in the calculation. So we'll use the simplified form, and the simplified form of the standard deviation is sigma x square by n minus x bar square, where x bar is the arithmetic mean given by sigma x by n. So we have already obtained sigma x, which is 33.7. 33.7 divided by 12 is 2.8083 kgs. So that is our mean. So now what we need is total of x square. So the sigma x square indicates total of x square. Okay, it is not sigma x whole square. Your sigma x whole square is different. Sigma x square is different. So you should be careful. So they are not same. This is capturing the total of square of every value of x, whereas this is capturing the square of the total. So square of the total, total of squares, both are different concepts here. So it is not 33.7 whole square. So what you have to do, you have to square every value of x and then obtain its total. So that's why I have written the values of x in the column. So always, problems related to means and deviation and other measures, please write your xf in the column so that additional columns can be inserted and the values could be easily obtained. Now compute the square of every value. 1.9 square, 3.61, 2.1 square, 4.41, 2.5 square, 2.8 square, then 2.9 square, 3.1 square, 10.24, 3.5 square. So this total is sigma x square. If we add them up, it comes to 97.99. Now substituting that value in the formula of standard deviation, we'll get our standard deviation. Sigma x square by n minus x bar square. So this is square root of total of x square 97.99 divided by n, which is 12, minus x bar square. X bar is already computed here. So we'll make use of that, 8083 whole square. So remember, all these are in kg. So you have sigma x in kg, sigma x square, kg square, mean square is also kg square. When you take the square root, the unit automatically becomes kg. So 97.99 divided by 12 gives me 8.1658 minus 2.8083 square, which is 7.8865. Now obtain the difference of that and then take the square root. This is 0.2793 and square root of that is 0.5284 kgs. So this is our standard deviation, we also indicate standard deviation by sigma, or since it is a sample case, we'll use the symbol S. There is nothing wrong in this case if you call it a sigma or small s or sigma. So this is how we compute the standard deviation. Now doing x minus x bar whole square for every value of x is time consuming, and since our x bar is a non-recurring number, recurring number, there no decimal part. So we'll have some error when we do x minus x bar whole square because we'll be capturing only 4 digits. So this method gives you better answer other than the other. So this is about standard deviation. Now the question says compute standard deviation as well as there is this 2.2.2. Compute standard deviation and variance. If you are separately computing the variance, then you can use the formula of variance. Variance is almost similar to standard deviation, but it doesn't have square root. But if you already know the standard deviation, the square of standard deviation is the variance. Now, since we already know standard deviation, the square of that number will be in the previous step only. So then directly write 2793. And since it is the square of x as well as square of mean, the unit gets kg square. So variance of this distribution is 0.2793 kg square. Next, we need mean deviation from median. Remember the formula, mean deviation from median is given by total of mod x minus m divided by n. We'll also look into coefficient of that. Coefficient of MDM is given by MDM divided by n. So we need to compute the value of median. So median m is given by the definition middlemost value or n plus 1 by 2 value of x. It is very easy to obtain this. So I have 12 values. So the two middle values are 7.84 and 2.8 and 2.9. Okay. So even if you apply the formula, you get 13 by 2, which is 6.5 value. That is in between 6 and 7. So if you expand it similarly, how we expanded the quartile formula, we'll have 6th value plus 0.5 into 7 minus 6. Now median, we will have the position always ending as 0.5. So 0.5 indicates the average of these two. So without substituting and expanding, we can simply take the average of that, which is 2.85. So there are two methods of finding the median. This is called as the inspection method. Since it is middlemost value, capture the middlemost value. In case of even number of observations, you will have two middle values. So take the average of that. Or if you want to use the formula, it is n plus 1 by 2 value, 12 plus 1, 13 by 2, 6.5. When you expand it as 6 plus 0.5 into 7 minus 6, and when you substitute 6 and 7th value, you'll end up getting the same answer. So we have got the value of median. Now from this, we will look into mean deviation. Now since it is raw data, we don't have f in the formula. So MDM is given by total of mod of x minus m divided by n. So for every x, now we have to subtract the value of median. Only consider the positive or the magnitude, ignore the negative sign, obtain the total of that and compute the average of it. So we already have the values of x in the column. So now what we do, okay, so next column will have mod of x minus m. So what is this mod of x minus m? From every x, subtract the value of median. ignore the sign and just write the number. So 1.9 minus 2.85. So I have to put two straight lines. Just the mod. Don't use common bracket. So I'll get minus 0.95. But you just take the magnitude. That is the number 0.95. Next you have 2.1 minus 2.85, which is minus 0.75. So just take the number 0.7. Next 2.5 minus 2.85. So we'll get 0.35. 2.8 minus 2.85. 0.05. 0.05. 2.9 minus that. 0.05. Then 3.1. 0.25. 3.2. 0.35. 3.4, 0.55, and 3.5, 0.6. So these are the values of mod x minus m. Now capture the total of that. It's coming to 5.3. So MDM is 5.3 divided by number of observations 12. So this total of x minus m by n, this is 5.3 divided by 12. 0.4417 kgs. So mean deviation from median is 0.4417 kgs. We have computed median, and we know that for every distribution, median and second quartile are one and the same. So we have second quartile as 2.85 kgs. So we'll capture this Q1, Q2, Q3. We'll also see how to compute the skewness values also using both Cartesian as well as Bowley's method. So this is MDM. Now coming to coefficient of MDM. Now the procedure is same to compute MDX bar, that's mean deviation from mean, and MDZ, which is mean deviation from mode. So first step, capture your mean mode like this, and then from every value of x, subtract the mean or subtract the mode, create a column, obtain the total, take its average, that produces MDX bar and MDZ. Now, coefficient of MDM is the value of MDM, which is 0.4417, divided by the value of median, which is 2.85. So both are in kgs, so they get cancelled. So you have a unit free measure. 0.1549 or 0.155. So this is the coefficient of MD. Any doubts? I can go. So look into skewness. So there are two methods. First one is Carl-Pearson's coefficient of skewness. It is based on the measures mean, median, mode, and standard deviation. So it is actually x bar minus z divided by standard deviation sigma. But in this problem, if you look into the values which are repeated, so you have 2.4 repeated twice, 2.8 repeated twice, 2.1 repeated twice. So we have three modes. So Z mode is 2.1, 2.8, and 3.4. So there are three modes. So we can't pick one value and use it for the calculation. So in this case, we say mode is not properly defined, ill-defined. So in that case, you can use median, and then the formula becomes 3 times of x bar minus median divided by sigma. So we have already computed x bar, median, and standard deviation. So we'll use it. And we'll clear this part. Okay, so I have x bar, I have median, and what was the standard deviation? Standard deviation was 5284, right? Now substitute that here and obtain the coefficient of square. So 3 times of x bar